Assalamu alaikum. Bismillahirrahmanirrahim. Numericals of thermochemistry, and today is question number 21. Dear students, in this question number 21, you are to calculate delta H for the conversion of graphite to diamond. In the question, heats of combustion of graphite and diamond at 25 degrees centigrade and 180 amp pressure are given, which are minus 393.5 kilojoules for graphite and minus 395.4 kilojoules for diamond. So with the help of this data, you are to calculate enthalpy of transition, that is conversion of graphite to diamond. Dear students, you know that both graphite and diamond are allotropes of carbon. Graphite is more stable than diamond. So as we have done in the past, the same practice is here. At the very first step, at the top of the page, you can find that I have written the required equation, that is carbon. Basically graphite is element, graphite's element is carbon. So carbon, and as a subscript you can find graphite, then arrow, and after arrow carbon, and as subscript is diamond. That is, this transition takes place, then there will also be some heat change or enthalpy change, and we are to determine from the data that enthalpy change or that transition, enthalpy of transition. Delta H equal to question mark I have placed in front of this equation. So after writing this equation, you are to write equations which have been given in your problem, and this data is manipulated so that we can get the equation which we have just written. So as number one, as I have encircled one, as number one, you are to write first equation according to data, that is heat of combustion of graphite, that is provided, and you are familiar this heat minus 393.5 kilojoules per mole. It means that in the question which we have done so far, the combustion of carbon heat that was given, which was of graphite. So in equation 1, write at the left hand side as reactants carbon, graphite plus O2 gas, and after arrow carbon dioxide, that is also a gas, and after semicolon you have enthalpy of combustion under standard state, that is delta H naught C, and its value would be minus 393.5 kilojoules. So this is the equation which you have written time and again during thermochemistry problems. After writing this equation, you have in the data enthalpy of combustion of diamond 2. So as number 2, you are to write carbon, and this carbon is in the form diamond, so you are to place the word diamond along with carbon. So carbon as a diamond, carbon in a diamond plus O2, and it gives carbon dioxide, and during combustion of diamond the heat release is minus 395.4 kilojoules. So you are to write this heat value along with the reactants and products when you write equation for the combustion of diamond. Only then it is a thermochemical equation. uh, Dear students, you know that we are required diamond in the product side, because in the question we are required graphite in the reactant sides and the diamond in the product side, and you have written equation for the combustion of diamond as equation number 2. So in order to bring diamond in the on the product sides in your final equation, what you are to do, you are to reverse this equation, or you are to subtract this equation. So since reversing is simple, that's why I have adopted that method. So now you are to reverse equation 2 and write it as equation 3. When you reverse equation 2, you will have carbon dioxide gas on the reactant sides, and after arrow you will have carbon as a diamond on the product side, and of course along with carbon there is oxygen. And to keep in mind that your sign that was previously negative in the enthalpy of combustion of diamond has also been reversed, has also been changed. Now it would be a positive sign. So CO2 arrow carbon, that is diamond, plus O2, and after semicolon you have enthalpy for this reaction now positive, not negative, positive 395.4 kilojoules. So when you reverse this equation, you have carbon diamond on the product side. Now simple thing is that you are to add that equation 3 and equation 1. Equation 3 as already written, so write below equation 3 equation 1. Equation 1 is for combustion of graphite, and graphite should be as a reactant, so it should be on the left hand side. So when you add equation 3 and 1, you are also to add their enthalpy values also. So after addition, you get your required formula equation, that is carbon graphite on the reactant side, and after arrow carbon diamond on the product sides, and enthalpy value is, since 395.4 is positive now and 393.5 is negative now, so enthalpy value would be 1.9 kilojoules per mole. It means that when you convert 1 mole of graphite into 1 mole of diamond, you are to provide 1.9 kilojoules per mole of heat. So that was our required equation, and this is our required answer of this question. So in this way you can do calculations, and this is a very simple question. And if you are familiar with the journal process which you have carried out in your previous examples, then this question is no problem at all. And these two are allotropes. You have also perhaps studied in your solid state chapter, where allotropes of oxygen are given, allotropes of sulfur are given, and also allotropes of carbons are given there. So I hope that now you can solve thermochemical problems quite easily, and it is your today's work. You are to solve this question. This is a very simple question. This question may be a part of short question because it is not very much long, and you can write formula of this question, write equations for this question, because you know that diamond and graphite are basically elemental carbons. So when they are elemental carbon, very simple, you are just to write their equation with oxygen, manipulate and get required equation. Thank you. Okay, Allah Hafiz, Pakistan Zindabad.